Hello everyone. Welcome to Data Science Foundations, an introduction to your data science and AI journey. My name is Sumudu Tendakon. I'm a data scientist with over 5 years of experience in data science, machine learning, and AI domains. I'm conducting this Data Science Foundations educational series to increase data science and AI literacy in the general public. There, I'm sharing my knowledge gathered over past few years as well as my career experience with you all. Hope you will get benefit out of it. Last year, in the year 2022, the world was shaken by a technological storm in generative AI. AI applications such as ChatGPT and DALL-E and many more came to general public use. They are made available for everyone to use. Most of them are for free. This quickly gained popularity, attracting millions of users within a short period of time. While some people believe the generative AI is a revolutionary breakthrough that marks a turning point in our human history, which brings our human civilization into the next level. Others are skeptical or concerned about its potential impacts, mainly negative impact or impacts with high concerns on the society. We should accept both sides. Both have like a lot of valid arguments. We should think how we can make this technology is a better one actually to bring our human civilization into the next level. From my point of view, it is great that the general public is talking more and more about this technology, discussing about it in social media and day-to-day conversations, and also getting more familiar with it. That is a really great thing to have in a technological development world. However, we also witness some individuals are exhibiting irrational fear or unrealistic expectation. That is an alarming thing. These attitudes will go into a bad direction, which makes our technological development is going to be in hold, or the technological development will be going to a different direction than what we should go. So this can further intensified by inaccurate or incomplete information being shared in the general public in media, social media, and various other sources without having the proper understanding. People share things and people getting to know from wrong sources with wrong information. That could be a major thing like impacting on this development. Such information has potential to hinder the progress of this fascinating technology, as well as it can adversely affect on the decision-making abilities of individuals in social and business leaderships and other individuals like all of us. Therefore, we should be thinking more and more about the technology as well as the social impact on this, how we can make it better, how we can make the best use out of it. With that, in my previous video, we discussed about some important realization of this technological hype we are seeing these days. Many people who talk about AI actually don't use it. So they are not actual users of it. They're just talking about it. Only a small group of people taking advantage of it and become actual users, and they're using for real work in their day-to-day life. That is represented in green color patch in this slide. Even very small number of people of the AI users are actually using with understanding. They have at least the basic AI literacy. They know what is happening. They are actually users of it. The group is even smaller if we consider people or the group of people who actually build these tools for the users on the other groups. Even this group that is represented in the yellow color patch. So they know how to build things using available methodologies and technology and platform. Then there's a very small, or I can say minuscule group of people who are actually doing the research and development of this technology and new methodologies and formulating theories and building some tools. So those researchers in academia and industry both, those are the people who are bringing this technology or concepts into life, and those can be used by other people to build different applications as well as to make use of them. So this is the situation we have right now. As professionals and educators in the field of data science and AI, our aim should be to fill this gap of AI and data science literacy in general population. What we are going to do. So we can increase this blue patch in this diagram, which is like people who are having the basic data science and AI literacy. We can span it across a large population. So we should be able to do that with more education and sharing our knowledge as professionals and people who are working in the industry, and having more fruitful discussions, or like having more productive discussion, I can say, from social media, other media, and our educational activities. So that will be a very beneficial thing for us to bring this technology into the next level and to help our human civilization. All right, with that, let's move forward with our topic today. In this video, I will discuss a practical use of generative AI, which is a question and answering system. I have been studying various techniques, platforms, and tools for creating question and answering applications and information extraction for various tasks. As a data scientist, I'm particularly fascinated by AI and especially interested exploring natural language understanding and processing. To be honest, before the ChatGPT breakthrough last year, I wasn't very optimistic about generative AI aspect of this natural language workload, despite my learning about the concepts and following the advancements of the technology. Late last year, I decided and I dedicated some time of my personal learning time to learn about this fascinating technology of generative AI, how to effectively apply it in applications solving real-world problems, using both open source pre-trained models and platforms available out there, as well as cloud services like ChatGPT. I hope you also interested learning about it. My main intention here is to give you a basic understanding of how a question and answering system powered by generative AI works and its main components. And if you wanted to build your own, I wanted to give you essential instructions or knowledge how to build things in your own, the concepts. That is what my main intention. There are plenty of resources out there. You can read several blog articles available, many different YouTube videos. You can find out a lot of things outside. Here I'm more specifically focusing on the concept and giving you the basic building blocks of building such a system. With that, in one of our previous video, we discussed about AI modalities. Our current application we are exploring is question and answering, which involves natural language. So therefore, we can understand, so this is in text modality. So we discussed about other modalities, image, code, music, video, and several other. We learned the capability of AI system is limited by its modality. If you train a model using text data, that model is capable of working with natural language type of task. If you train a model with both text and images, so we are connecting two modalities, that those models we call multimodal models. So they can work with both text and images. So they can use for various useful tasks. But in this application, we are going to use text modality, the models trained with text data. With that, we all know these large language models as a topic in the hype we are talking about these days, like the ChatGPT, DALL-E. DALL-E is an image-based application of generative AI. And then we talked about Google Bard, which is another generative AI chatbot application powered by large language model. So what is large language model? So let's first try to understand it. So what are they? What are the large language models actually are? So they are basically machine learning models. They process and generate natural or human language. Why we call them large? Those models are made of neural network with large number of parameters. I'm not going to go into very technical details, but you can find out any information about how neural network architecture looks like. What I mean by the large parameters, you will find more information if you do a little bit of search out there. But for this learning exercise today, you don't need to go into that detail. I may also do a separate video about introducing the architecture of these models, but for now, think they are huge neural network using like large number of parameters. And they also use another large thing, which is train on large amount of data. Why we call them language models? So large language models, why we call them language? That is because they are trained on text data. We already knew that. Language models in the text modality. And they are capable of processing and generating natural language like human does. How they got trained? So you may be curious. If you don't know, so this is why. So they train on huge amount of text data, such as books, articles, social media posts, and many more. You can think of like entire Wikipedia feed into a model training. So the model is learned from the Wikipedia articles. So the model learned patterns of human writing or the natural language, the structures and the patterns in the natural language, examples given to the models in the training. With that, what we can do with language models? You already know these things, but to have a better understanding, I wanted to put this slide before we move forward. So having the better understanding on the concepts and better understanding on the terms, it is very easy for you to learn this technology further. So that is what I am doing this. So what we can do with it? We can apply large language models for text generation, summarization, translation, question and answering, sentiment analysis, and many more natural language related tasks. Those models can be generalized for many applications. The models can be trained and then used for different applications. In the previous video, we talked about foundational models in detail. I'm also reintroducing it today for your added understanding. So what is foundational model? We can now stick with the language models, large language model as a foundational model. So those foundational models are the models we can use right away from the model, like a pre-trained model. We can get from various sources. Like today we are going to explore Hugging Face and other various sources, and different companies also contribute foundation models as the open source initiatives, and they are available for you to download and use right away without training. But there's an option. You can do fine tuning. You don't need to retrain them, but you can fine tune into your application. You can also use directly without tuning. If you were to do the fine tuning, you can use your own data, both label and unlabeled data. You can run fine tuning exercise and you can let the model optimize for your specific domain. Again, even without training, we can use for these general applications such as text generation, question and answering, information extraction, text classification, sentiment analysis, and translation. Same model. You can tune in a way, so you can use in a way in any of these applications. You don't need to change anything in the model, but there's a catch. What is it? You have to learn and understand how you would provide input to these models. For each application, the model will interpret and model will respond to you in a different way on how you give the input to it. You may not give the same input for Q&A application as the way you give for the text generation or the information extraction. For translation, you may give your input in a different way, but it's not very different. The way you organize your input values into the model will be different. So we will learn today how we can do that with question and answering application. Later, we will discuss how to do the general text generation applications and some classification applications. Sentiment analysis could be a part of classification, and do translation. All right, so I hope you have now a better understanding of foundation models and how you are going to use them. Okay, so now let's look at question and answering, which is the topic for today. Before we begin, let's think what is actually question and answering. So we use this terminology in our day-to-day life as well. When you walk on a street, someone may stop you and ask direction to go to a specific location. Maybe how I can find the library. Or maybe at your work, people always can ask you a question. If you're working on a reception desk, people may ask you questions every time when they come to your building. So like that, people always ask questions, as well as people should expect questions from others. So what we do, if someone asks us a question, we will respond to that question with an answer. What is expected in this question and answering workload? Our expectation or the objective is to provide accurate and concise answers to natural language questions. You should not answer incorrectly. You should not give irrelevant answer for any question in a day-to-day life as human. So what we are trying to do, we are trying to let computers to answer our questions. So we expect this thing at least the base minimum. So now let's try to understand this question and answering with some family examples. Assume we have two people here. Mike, who is a student, Alice is the receptionist. Think about a school. So Mike wanted to know something about the next year course enrollment. So he's going to visit the receptionist. So he's going to ask, how can I enroll for the generative AI course in the next semester, we can say. So Mike is asking a question. So Alice is supposed to give an answer. So what should Alice provide? So she may have some training within the department to answer similar questions. She may have some knowledge. So she has enough knowledge to answer this question. So what she would do, she would use the internal knowledge, and she would say, okay, you can register for the course using online portal, and maybe she can give other additional information, but within her own knowledge. She is not going to consult any other thing. So that is the example one, answering question directly with the knowledge the person already has. So Alice is doing that right now. So let's look at a different example. Example 2. So this is a question and answering with expert assistance. Assume Alice don't know the answer for this question. What is the question? So Mike is asking, I did not take advanced math class in the previous semester. Can I still enroll? So what would Alice going to say? So she didn't train on providing this answer to a student. What she would do is, she will say, okay, I need to check with my supervisor, or I need to check with someone else. So she may go and ask the question from the supervisor. The supervisor may not be the person who is actually giving the answer. She may also ask another person. That can happen in real world, right? So that is possible. Let's assume Sam, who is the admin of this department, he's able to provide the answer. But would Alice ask the same question as student? Probably not. She may modify it a little bit. In her own word, she may ask the question from Sam. So Sam will provide an answer for the forwarded question. So when Sam provide that answer, so Alice take that answer and she will process internally in her brain and then come back to the reception desk and providing answer to Mike. So answer could be, you only can audit the course this semester. So she may instruct based on what Sam told her earlier. She may instruct how you actually take the class for credits in the following semester after taking the math class. So like that, in the second example, Alice used an expert assistance to find out the answer for the Mike's question. Let's look at a different example now. Example number 3. This is an example still with an external knowledge Alice need to bring in because she don't know the exact answer, but she wanted to refer something else. So she may refer some documents. It could be electronic documents, it could be physical documents in this question. What is the question? Mike is now asking, can I get the course contents? He may interested now in the course syllabus and who is the teacher, etc. So when Mike asks this question, what Alice is supposed to do? She don't need to go back to Sam and ask this question, but you can do some simple search in the system and find out what are the materials available to get this answer, or to provide some materials to Sam to help him finding the answer. So she may do some search, electronic or the documents. So she may search in some external knowledge. So once she's found that relevant knowledge to provide the answer, she may give the answer back to Mike with some references. In the real situation, she may give some hand notes, or maybe some leaflet to Mike to get to know more about it, or maybe she will take a printout of the course syllabus and give to him, or she may email. So in that answer for the question Mike raised, so she may give answer plus some references. So this is the third example we discussed in this exercise. All right. So now let's try to understand a little bit more about this searching in external knowledge. In the previous example, we talked about asking a question from an expert, and the example 3, we asked about searching external knowledge. So this is what we usually do in our day-to-day work as well. Even for a self question, right? If you have a question in our own, we do a search in a web browser, or maybe a system we are going to use in our organization, or maybe in our school. So what we do in this external knowledge search, we usually do keyword search. So if you have a document, we can always search by a keyword. If we know what we are searching for, we can type some keywords in, and we can go to the location of that document by the keyword search. Or we can use table of content. We can always use index if you are searching in a booklet, or like maybe a dictionary or a book. So it may have like some index you can search for. There are many different ways you can search external knowledge. If you are using electronic medium, so it is much easier. I don't need to explain it further. In these searches we discuss, we have some important thing. So that means we are only considering the words as it appear by the word value, but we are not considering about meaning of those words. Sometimes it is a matter of the meaning when we wanted to find something out. Let's take this example. So the example sentence below: time flies like an arrow, fruit flies like banana. In this example, what we have some words, right? So time flies like an arrow. Pay attention to the words in color. Flies is in pink color, like is in green color. So let's look at the flies. The flies word, in the first occurrence, the time flies. So what does that mean? So that flies means a verb, right? So time flies like an arrow. It's still having some ambiguity, because time and verb flies may not be sounds that going together in our common sense, but we can say like time flies. But the second occurrence of the flies with a fruit, that means a fruit flies. It's an insect. From human understanding, we know that. Okay, so think about how machine can understand that. If we wanted to let machine to understand the meaning of it, right? So that is what we are going to learn in the next few slides later. So now let's pay attention to like word. The first occurrence of like, so time flies like an arrow. So that is something like similarity of two things, right? Time and like a flies like an arrow, kind of comparing to something. The second occurrence of like, what does that mean? The fruit flies like banana. So that means an affection, or the fruit flies is kind of having some connection with banana, or maybe like the fruit fly wanted to get into banana, something like that, as some affection. So the two words like, it appears in the same way on the sentence, but have different meanings. So when we search some external resources or some documents, if we did not apply this semantic search, or in other words, we can say considering the meaning of it, we may not find relevant information efficiently. As a human, we can do a keyword search. When we get the relevant content, we can process and understand. But computer has no ability to understand as human does. We need to provide some way it should understand it, that we call semantic search. Semantic search is something we are going to use to find relevant content from external documents in a Q&A application. Okay, so let's try to understand how this is going to be implemented. So before we are going to go into that discussion, let's try to understand different types of question and answering systems. The first type is we call extractive. So what is extractive? In an extractive question and answer system, we are extracting answers from a given text. We are using techniques such as information retrieval, named entity recognition, or semantic parsing, like I just explained previously. These answers can be given with links to the sources those answers containing. If it could be in multiple documents or single document in a specific section or paragraph, we can give where we find this. That is the extractive way of providing answers in a Q&A system. What is the other method? That is generative question and answering method. What we are doing here is we generate answers based on the context provided utilizing the generative language models. So we are going to extract, and then we are providing that context to a language model. I will give you some examples in the coming slides. And those language models will generate an answer for the question, like Alice did earlier. So she got some information either from documents or either from asking another expert, but she's not going to give the same answer back to Mike, but she may process internally and give her own answer based on what she finds. So that is what a generative question and answering system does if it uses some extractive part within. There are other generative type of answers. Those generative question and answering systems, they don't use any external sources like ChatGPT initially. So it is being trained on huge amount of data before 2021, the latest release of ChatGPT GPT version. So therefore, it trained on that data. It cannot answer anything after that. There's a limited knowledge. So those models, if you employ them in Q&A systems, so they can only answer based on their training data or within the training data context. It doesn't consume any other external sources or external context to provide the answer. We call them closed Q&A systems. So that is also generative. The answer is generated directly from the model without consuming any external knowledge. But if you use external knowledge, so that could be extractive plus generative question and answering. That is what we are going to explore in this lesson. Okay, so let's talk about another special case. This we call long form question and answering, which called LFQA. What does that mean? Like when we ask questions, sometimes it could not be a direct answer. It may not be a short answer we expect. We expect some long description. It could be some list of things, or maybe list of instructions, or could be some paragraph long answers. So those could be long form question and answering workload. We are not going to discuss it today, but for your understanding, what they do, they provide in-depth answer to open-ended questions. So they use information retrieval from documents. Of course, you need to refer something and put together into a detailed answer. And they use generative language models, large language models, to produce paragraph length answers based on the knowledge acquired. All right. So now we have some understanding about the question and answering types and how they are being used. So let's try to get some in-depth understanding of question and answering use cases. What are the use cases we can apply this if we were ever build one? The most common application will be customer service. We already have some question and answering customer chatbots, so we interact with them. We sometimes build in our workload. So we can easily deploy some generative AI question and answering chatbots to customer service to provide answers to customer questions. Generative AI question and answering system, or question and answering in general, can provide some virtual assistance to HR related work, or maybe IT help desk, maybe to refer to a guidebook or frequently asked questions within organization. So that could be a good use case as well. It could be within organization. It may not be available to your customers, but to ask general question. For example, human resource department can have a chatbot to help employees to get answers for their employment related questions, benefit related questions, like that. There are other applications like document content and query and document search. So you can, if you have a large set of documents, you can use Q&A systems powered by generative AI to search, find information, and get answers for your questions found from the large set of documents. You can also use generative AI question and answering system connected with your data to provide reports based on the question you ask. It will generate a report or even a visual in some situation. It could generate a report, or it could give a direct answer by doing some analysis internally. You can use these question and answer systems for market research. It can also apply for data analysis and asking question and finding the results. And also, you can use generative AI Q&A to get information from your subjects in market research. Instead of going people deployed into collecting information or to collecting feedback from your subjects, you can apply generative AI application for certain things. Generative AI can also be used for learning support for students and teachers. Also can be useful applications if you have a Q&A where generative AI applications to help student questions. It could be subject related. If you train a generative AI application responsibly enough to give accurate information for student subject related questions, as well as the question we already explored earlier about general questions like how to enroll for a course, how to complete this course, some requirements or something. Learning support will be a good thing we can provide with a Q&A application. We can take some load out of teachers at some point. Generative AI based Q&A question and answering system can also be employed in entertainment. We have seen some of the entertainment applications like your companion chatbots. People who are living a lone life, so maybe they don't have someone to talk to. So they may use generative AI chatbot to have some companionship. There are good things and bad things, and huge responsibility for the builders and maintainers of such systems, but that could be one example. People can use for some entertaining activities as well. So you can have a chatbot trained like your favorite movie character and interact with you and answer your questions, something like that. So there could be various interesting applications of generative AI chatbots and many more. So there we can find out many more applications of this. All right. So now with that understanding, so now let's try to understand how we can actually build one such application, generative AI application for asking questions from document collection. Maybe in your organization, you may have like large collection of documents, or maybe you have your own class notes or your research notes, typed it in, and you may need to find out some answers for certain questions. You may not have a lot of time to go through each and every document. For example, if you are a lawyer, if you are someone who is dealing with large or lengthy documents, you may not have time to go through each and every part of your document, but instead you can give that workload to a Q&A application to search information, find out what you need, and provide you the answer you require. So this is what we are going to explore. Asking questions from your own documents. Like Mike asked the question from receptionist, now Mike can ask the question from this chatbot. So the chatbot's supposed to go through all the school documents, finding out the relevant information for his question. So therefore, he can get the answer very quickly by having a chat with the system. So he may ask the question, chatbot's supposed to provide the answer. All right. So now let's try to understand how this AI-powered Q&A systems work. And my goal here is to introduce you part by part and to give you a basic understanding of each part of this Q&A chatbots or the Q&A applications or systems, and I hope this will give you a better understanding of how things work internally. Let's move forward with that. So now let's think. Say Mike wanted to interact with the chatbot, so he may ask a question. You all know what we can do with chatbot and how to use it. So you type your question on the text field. So then you can press enter or the submit button. So it will take it in your question in, and then it will respond. It will take second or like a small amount of time to process the answer and give you process the question and give you the answer. But it will eventually provide you the answer. How it is going to provide you the answer? That is the important question here. So it will take your question in. Your question will be in natural language. And internally, like Alice did, so the Q&A bot will go and search relevant documents or data. The relevant means relevant to your question. The relevant to actually the Mike's question in this case. So combining the question and the relevant data, we can call the knowledge or the context. It will provide it to the language model. So it provides few different things. The first one is instructions. The second one is the query. So we will talk about more later what are the instruction, query, context, and chat history. What are they? But in this workload, the chatbot is supposed to get this information from the documents, and then it will get your question. And instructions are something we give instruction how the chatbot should behave and what it should do, what it should not do. In an ambiguous situation or unable to find the answer, how should it respond to those instructions? Like we give to a person who is getting employed in our organization, they have some policies and rules. So this is what we are going in the instruction part. And then the context, we talked about it, and then the chat history. So chat history is something, if the person is keep chatting for a long period of time, so the model can also get benefited from that chat history, knowing what the conversation is about, what is the intent of the user of the chatbot, like that. So with that, language model will take them all together and process internally and provide you an answer. This is in very high level how a generative AI powered chatbot will work. We have generative and extractive both employed here. Okay, Mike will get the answer eventually. Now, with that understanding of the application in very high level, so let's try to understand a little bit of deeper of main parts of AI-powered Q&A system. Any system, we need to have some kind of interface for user to provide the question, and also the same interface can help user to get the answer back. That is the user interaction. So the interface is something very important for us to build with the AI-powered Q&A system. The other important part or the component of the system is information retrieval. We'll talk more about it in a short while. So which is basically using your knowledge base. It could be your collection of documents have you within your organization. The information retriever is supposed to search relevant content relevant to your question. And the knowledge base, that is what information retriever actually use. The knowledge base is the next important part of your system is. So that contains all the documents for put in a special way. We will talk about how we can put your documents into knowledge base, not exactly the documents as it is. We need to do some processing and then put it into the knowledge base for the information retriever to use it and effectively get the information. And the next part of a Q&A system is language model. So you all know what is language model now. So language model is supposed to understand the question and also get the knowledge and give you the answer for that question. So those are the 4 important things as I see in this basic application we are going to discuss: interface, information retriever, knowledge base, and language model. We will talk in detail how we can build each of these components. And also we're not only discussing the concepts. In the next video, I'm going to discuss with you how we can actually build as a Python application using Python programming language and other open source models, the pre-trained models, as well as frameworks and libraries available for you to use for free. Okay. So now let's try to understand how we can assemble a prompt for generative AI powered Q&A application. So what is this prompt? I'm getting the word, kind of a technical word if you're not familiar with it, but you heard this word before. So the prompt is something we are going to give into the language model. So we can call the language model prompt. So that consists, so these are not new to you right now. We already discussed this before, but now you know the technical word for to call the thing we are going to send to language model. So the prompt consists of your question or query, external knowledge, get from your knowledge base, and the system message that we call instructions or set of rules, how your model should behave when someone asks the question or when giving the answer back to the user, and the chat history, or we call it memory. So the conversation happened with the same user within a period of time. So you can keep it as the chat history. So these are the things you will be sending into language model if you are using this language model, or the language model here could be like a foundational model. If you're using it for Q&A task or Q&A workload, so this prompt consists of these 4 items. In some situations, you may miss the chat history because that application does not require to keep the chat history. Maybe some application does not require, like I mentioned to you, if it is a closed Q&A, does not require external knowledge. In some applications, may not require to give the instructions, but typical Q&A instruction is something we'll always have. Question, instruction, external knowledge, and chat history. So that makes your prompt for the language model. So what the language model is doing with this now? So it will take it in and give you the answer back. We went through this concept again and again in previous times. Okay, so with that understanding of things, so let's try to explore extractive AI example with a real application. I will give you this example in our Python exercise in next video, but I will only show you the outcome of this exercise. So here I'm going to ask a chatbot application or a Q&A system I'm going to build with you in the next video. I'm going to ask the question, why is the sky blue? This is like a physics question, but you probably will have the same question when you're looking at the sky without clouds. It's always blue. Sometimes you will see in a beach or somewhere you may see different colors when sunset and sunrise, but generally it is blue, right? So that natural question. So why is the sky blue? We're going to ask it from a language model. What it's supposed to do? If the language model trained with a context related to this giving this answer or this subject, it probably can give you the answer as a closed Q&A, but assume we give the context. Okay, so in this example, the first example I'm going to discuss with you in the next video, I'm going to give the context to this question. And then it will try to process the context and question, and the large language model will provide you answer. The answer will be Rayleigh scattering. So I'm not going to describe what is Rayleigh scattering in physics term, but here let's stick with our understanding of generative AI and natural language understanding and processing. So this provides the answer. So I can accept the Rayleigh scattering is the reason how we name it, but the answer is correct. So this is what the language model does internally. You will not see what is happening internally actually, but you will see in a program code what we are going to give to language model and what we are taking out. So the question in this Python code, I put the question as a string, why sky is blue, and also I am copying a paragraph I took from Wikipedia article about Rayleigh scattering. I copied this paragraph. It is not directly giving the answer why sky is blue in the paragraph, but it has some information for someone to derive that answer. That is what language model does. It has the Rayleigh scattering word, but it will not directly say sky is blue because of Rayleigh scattering, but if you read the paragraph, you will guide to that answer. Okay, so we give the question, we give the context. So the language model, we are putting language model behind this function. So what this function is, get answer function. We are providing question, we are providing the context, and the LLM pipeline, you can think of the language model, the pipeline connected with the language model, which accept input and produce the output. You can just have that definition for now. We'll go into detail when we are discussing the actual Python code with this. Okay, given the question and context, the answer will be given from the model. So the answer actually we got was really scattering. So that is what is printed. You will see that in the application when I'm going to show you in the next video. In this exercise, I'm going to use the model from DeepSet dbeta v3 large squad 2 model. So that model is what we are going to use first. This is from Hugging Face AI community resources. Okay, so now we use extractive Q&A example, getting the answer from the text given the context. So let's do a little bit of advanced stuff. So we can use a different model. Now I'm going to use a different model from Microsoft Godel version 1 model. So that is a dialogue model. So that can do the generative part and extractive part both. So here I'm going to provide instruction, so which is we didn't provide earlier. The instruction is, given a dialogue context, you need to respond like this professionally and truthfully. Do not add anything outside the context. If you cannot find the answer, respond with, sorry, I could not find you an answer. These are some of the rules, some guardrails you can put into the instruction. Okay, so that is what we are going to provide to the model. The second component we are going to provide to the model is knowledge. Same as in the previous example, we provide the context. Only the variable name is different. We are providing the same paragraph. That is the knowledge this model is going to use. The third thing we are going to provide to the model is the question. In this dialogue model, we call a dialogue list because it can run as with a memory. If we implement it in a way, means if we provide all the previous conversation as a list of questions, we can feed it into the model. Then model will use that when the model is giving us the answer. Therefore, I'm going to provide this question list as a dialogue list. Then the same thing like before, we have the get answer function. We provide instruction, we provide knowledge, we provide the dialogue list which contain your question. In this case, this is the first question we ever asked from this model. Therefore, we don't have the previous conversations. We have only one item in this list. And then for this function, I'm going to give the model and the tokenizer. This is another thing we're going to discuss in detail with our practical exercise with Python code. Therefore, don't worry about the model and tokenizer. Just pay attention to these three items. Given instruction, question, and knowledge, the model will provide you an answer. This was the actual answer I got from the model. So now you can see this answer is extracted things from the paragraph, but the same answer you cannot find directly on the paragraph. It generated it for you. It's a Rayleigh scattering takes place through the interaction of light molecules. There are some things we need to adjust in this answer to make it a very reasonable one, but the answer is relatively correct. But I'm not going to discuss about the detail in science or physics with this answer, but the important thing we should understand, the language model process these three things and provide us a generative answer. That answer is reasonably correct. Okay, so this is generative Q&A example. It uses both extractive and generative things within the model. Let's try to understand what is the role of language model in this Q&A application. We all know large language models are capable of generating language sequences. What is the sequence here? Is a sequence of words. So if you think about a sentence, we know like a paragraph is made of sentences, sentence is made of words, and a word made of set of characters or sequence of characters. Because the order the character appear in a word has a meaning, so we can take it as a sequence and order appear word in a sentence as a specific meaning. So if you change the order, the meaning of the sentence can change. So we can have each word can have a specific position of that word sequence. So like that, we can model a sentence as a sequence. Let's look at an actual example. So think that in this example, I'm going to give you as a sentence. An apple fell from the blank. So you have to fill a blank here. So as a person, how would you take this challenge? What should be the word coming to the blank? So now let's try to solve it computationally. Let's now take our approach, take the sentence, split into words. An apple fell from the, so those are the words as a sequence. As you see below, the X is the word sequence, and we have 5 words here. Our goal is to find the 6th word in the sequence. What is the next item should come? If we have T number of words in the sequence already, what we're going to find? We're going to find the T plus 1 word. Okay, so what should be come to this position? What is actually the language model doing here? If you wanted to give this task to a language model, if you take the same sequence X as showed in this yellow symbol X, okay? So what language model is doing is actually, it is trying to find what is the probability or what is the chance of the next word or the word T plus 1 be a specific word, okay? As human, we have our own vocabulary. We know a lot of words, thousands of words, right? So we are going to pick one word out of all words we know to fill this blank. From our human knowledge, language model should also supposed to mimic that behavior, but how it select? That is a question. Okay, so if you think like language model as the function, given the sequence, what is the probability of selecting a specific word? And that could be the y, the probability or the chance of being a specific word. We can take it as a y. If the higher the value, we will have a higher chance of being that word replaced into the blank. So let's check the challenge now. I gave you a simplified challenge as a human. So you are given like these 5 words. What would you pick out of these 5 words to fill this blank? I have given sky, red, ground, tree, and table. As human, what we are doing is we are bringing our human learning. We have seen many sentences involve these words, and we know meaning of each of these words, and we can connect them, and we can try to understand what were these words and their meanings, and then try to find out the best or the most suitable word to fill this blank. You may not use the word red here. So you can exclude that from the first place because that may not sound fit, right? Not sound a fit to this sentence. An apple fell from the red. So may not be sound correct. But fell from the sky. The word sky could have some meaning. You may still would like to choose it. And the ground, you probably hesitant to use it, but fell from the ground does not have like a big meaning, but it's not something you can exclude from the first run, right? Fell from tree, so there's a high chance you have seen words or sentences like that before. Fell from table, that is also a possibility. Someone put apple on a table and it fell from the table, that is also a possibility. So sky, tree, table have higher chance. The ground, probably a lower chance, and red is no chance. So let's try to put some values to y. So y can take a value, we can say a value between 0 and 1. Higher the value, higher the chance of being that value selected. Okay. So with the word sky, we gave y a value is 0.5. Word ground, y gave value 0.1. Red, we give y a value is 0.0. And tree is 0.9. And table is 0.7. It is obvious. If the task of language model to pick the highest value of y, it would pick tree. Okay, as you would do. What we should do to train this language model to do the task like human does, if the training happen, if they are using a pre-trained model, it would go ahead and pick the word tree like human does, because it learned from human natural language written by humans, right? Or like the with the meaning and everything. So now it excluded all other things and selected the word tree. As human, I know most of you choose tree, maybe some of you choose the word table, very few of you may choose sky, and even smaller portion of you may choose ground, and I assume none of you choose word red. So the language model picked the value tree based on we can say probability or the outcome of the function we have on the left side. All right. So now we have some basic understanding of how language model is going to find the next suitable word, but we have more components, right? And also the language model is not supposed to choose the next suitable word, but it's supposed to choose like number of words, subsequent words as well, following the same way. Okay, so now let's look at another component in your question and answering system, which is information retrieval with a semantic search. So let's try to understand how it works, how to get the relevant knowledge from a system. So in this component, we basically getting the user's query or like a question user asks. We process, we take the document store. You may have like large collection of documents. Here I'm using a color code. Pay attention to the color. So color represent a meaning of each document. These documents could be various documents or a large document like a legal contract, or maybe a very lengthy document split into parts, and each part we can consider as a document. Each part may have some meaningful things inside. So we can think of color represent meaning of that document or document part. So the search query is in light blue color, and you may see naturally if you look at the color code, we have different colors. The documents in red, yellow, green, they are very far away from the color from the search query, may not be the documents you should choose as relevant document for the question, but the documents in close to blue color could be something you can choose. But if you have like one document in dark blue, it probably may not the one you should choose. Given your criteria, your retriever is supposed to pick the closely matching document by doing a semantic search. What is the matching criteria? It should match semantically to the search query. Okay, the meaning should be similar. So let's try to understand what is this mean. So in a semantic search, what we are doing is we are finding information matching to the meaning and context of your query. And we are making this search process easier and more efficient by giving more relevant and accurate results. So that's why the usefulness of semantic search over basic keyword search, because meaning is considered. And semantic search can use to find relevant context for natural language questions, finding synonyms and spelling errors, and many different applications you can get the semantic search. And it is not only applicable for language. You can also apply it for other data formats, images, video, audio, some document files, maps, etc. So we can apply semantic search for various data formats. So what is exactly this happening is we are going to give a meaning to individual data element here. So that meaning you can use to search later. All right, so let's try to understand how we provide meaning to our data elements. So let's start with words. Think of these 5 words: dog, cat, flower, puppy, and fish. As human, you know what are their meaning. You know some of them are having some connection to each other. For example, as human we know dog and cat we consider as our pets, even like fish we can consider. And if we take the word dog and puppy, so we can consider they are very close to each other. We can call the same animal dog or puppy. So that is a very close relationship, right? And flower, we know dog, cat, and fish, puppy, they are all referred to animal. But flower is not an animal, but it's a living thing. But we know like that is different from dog, cat, puppy, and fish. So like that, we know the similarities, dissimilarities, and the characteristics of each word. We know the meaning internally in our brain will process based on the meaning. For the computer, we need to provide some features to understand the meaning of these words. So here I'm going to provide three features: D1, D2, D3. When we take a word, so the we can take let's focus on the first row, say 0.5, 0.1, and negative 0.7. We can say those are the embedding vectors. So here the embedding vector for dog consists of three elements: 0.5, 0.1, negative 0.7. Cat, you have 0.6, 0.9, and negative 0.9. So now let's try to understand this concept a little further. So we may have this D1 with a specific meaning. Say like this could be being an animal. Okay, so that the number is given by that context. Also, we can say that is a feature. And D2 could be something else, and D3 could be something else. So let's try to understand it a little further with the word the values we get for each word. Dog, we get 0.5 for dog, and we get 0.1 for dog for D2. So 0.5 for D1 and 0.1 for D2, and D3 we get negative 0.7. So the D3 column, we get only the positive value for flower and fish. So we can speculate something like it could be something related to water. Okay, all animals need water, but fish lives in water, and flower, so we are watering the flower frequently, something like that. So we can think this is not the exact meaning, but we can think some ideas, right? So like that, when we create embedding vectors for each word, we can put them into a vector space. We can visualize and find out what words are close to each other. Here we have three elements in each embedding vector, but in actual application, we may have hundreds of elements. We can have 768, 512, 256, maybe 200. We can have like a specific number of elements in embedding vectors based on the tool you are going to use. But here we have only three for simplicity. Even with these three, if we wanted to take it visually represented, we need to draw a three-dimensional vector space here. We are not going to do that three-dimensional vector space to take the visual. Instead, I'm going to convert this three-dimensional into two-dimension by following principal component analysis method. If you don't know what it is, don't worry about it. That is not required for the Q&A application building, but I would encourage you to read and learn more about principal component analysis. If you are especially doing data science and machine learning, you probably need to have that knowledge. Basically, what it is doing is it is converting higher dimensional data into lower dimensional data. In this example, your 3-dimension converted into 2-dimension. It allowed me to plot your 3-dimensional data in 2-dimensional plot using x and y axis, like you are seeing on the right side. In this diagram, if I get the principal component analysis on this data set, actually I get from using these numbers, you will find out the word dog and puppy appearing in close proximity, because as human, the meaning wise, it is they are very close to each other as well. By using these values, you will get to know they are very close as well. And dog, puppy, and cat, so they are close by, and these three words are far away from flower and fish. And fish and flower is also having further away from each other. Therefore, we know like they have different meanings. So if you think of like you add a dolphin, the word dolphin, right? Dolphin is a fish. It may be appearing close to the word fish. If you have any marine animal living in sea or water, it could be in the close proximity to fish than to the flower and dog or puppy. Like that, the word embedding vectors helping computers to find out which words are similar in the meaning by using the embedding vector components or the elements. Alright, so now we learn how to do the word embedding, how to give the meaning of words into computers. So now we know we are dealing with sentences and paragraph in natural language processing. We are not only working with words alone. So words make sentences if I go the forward way, right? For example, think about these four sentences. Sam ate an apple. The traveler had a snake bite. John's puppy is cute. Jane has an adorable puppy. Okay, so these are like 4 sentences. By looking at them, think about the meaning of each sentence. What each sentence is going to tell you as a human if you were reading them. The first sentence, Sam ate an apple, which has a happy feeling. Someone ate something and the Sam could be happy. So here I'm going to give like the elements of this embedding vector with some a real meaning to it. Like, so I'm naming it as happy. The second element in the embedding vector I'm naming as food, and third element in the embedding vector I'm naming as animal. So Sam ate an apple, happy, involved food, and nothing to do with animal. Okay, so you can have like negative 0.7, very low value. Happy and food are having higher value based on the sentence, right? The meaning of the sentence. And traveler had a snake bite. It's not happy, so therefore the value is negative, very low value. And it is not involved food, even it's a bite word, but the meaning wise there's no food involved, and there's an animal involved which has a higher value, right? So that's what we get for the sentence B. And John's puppy is cute. Yeah, that's something to be happy about, and nothing involved with food, an animal involved. Then we say Jane has an adorable puppy. Again, something to happy about, no involvement with food, and animal involved. Like that, we can give the values for this embedding vector for each sentence. You may have now question how we can do this. Weird word. I didn't go into technical details or the details how we can actually give, but you can read more about it in many different resources. I'm not going to discuss that today in this video, but if I get time, I may do it in a later time. But think, somehow you give these values. In very high level, you can think of like we will get embedding vectors for each of these words, and we can aggregate them together, and then we can calculate the vector embedding values for each sentence. So some of the things we can do. There are many different ways we can do that. Okay, so now somehow we have embedding vectors for each sentence. Each vector will have 3 values. Now our goal is to plot them like we did for individual words. These 4 sentences. If we do the same method, we get like 3-dimensional data. I did principal component analysis and bring them into 2-dimensional for the plotting purpose. Now I have all 4 sentences plot together. As a human, can you relate what you get as meaning of each sentence and what the computer is seeing in the vector space, the embedding vector space? If we do the principal component analysis, we have in 2 dimension, right? As a human, we know the sentence C and D are very similar in the meaning. So both are talking about puppies, both are talking about like some cuteness of puppy, right? In both cases, those are meaningfully similar. In that case, we can find out the embedding vector for both C and D sentences are in close proximity. They are very close to each other. But sentence B is very far away from C and D, as well as far away from A, because they have different meaning. So A and B have different meanings than C and D, and the meaning of B is very different from A. Meaning of A is different from C and D as well. Like that, we can give this information as or sentences as embedding vectors to computer to process, understand, and process with the meaning if we use embedding vectors. Now, let's try to understand how we can make a use of it in our question and answering system. Now, assume you have these 4 sentences in your knowledge base. This is a like very simple example, but think like this is your knowledge base with only 4 sentences. They were embedded, and computer can understand with the numbers. Okay. So the question asks, who got the medical treatment? That is the question. You should be able to answer using these sentences. As human, what would you do? There's no mention about medical treatment, but you can assume, you can relate this question with something else. Sam ate an apple. There's nothing indicating a medical treatment unless apple is rotten or something wrong with the apple, Sam got sick. We don't have that information. But the second sentence, the traveler had a snake bite. It is something we know it's likely go with a medical attention. Okay, but how we can let computer to handle this task using the word vector embedding methods. So computer is capable of creating the embedding vector same as it did for the sentence, individual sentence. We can apply the same method to get the embedding vector for the question. In this case, the question who got medical treatment, it's not something to be happy, not involve food, no mention about animal, all got like negative values, right? So in this case, if we use this sentence with the embedding vectors, if we convert these three-dimensional value into two-dimensional vector, so we can get the position of the in this two-dimensional space, which is represented by the red star here, the question, right? So this question will have some meaning, right? So what we need to find out, we need to find an answer for this question. When we're going to find out the answer, we wanted to find out what is the closest sentence we can give a clue or hint to find the answer. So that the meaning of the closest thing we can change. But here, let's see, we are going to find out the region of like using a radius or something to find out the most or the nearest neighbor, we can say, like nearest neighbor sentence for this question, which is B. So you can control this parameter, like you can find out using some threshold. Here we have only 4 sentences. In actual application, you may have hundreds of documents or sentences you embedded, and your entire vector space is filled up. You can define your radius, or you can define a condition or criteria how you should consider a document or like a sentence from the word embedding to be relevant for the question. But here, let's see, this red circle defines it, and it finds out B is having a relationship between the question, or semantically related given the criteria within the red circle is the criteria. So we can find out the answer, or we can let the machine to provide you the answer based on the context we get from B. It will not get any context from C, D, or A, but only B, because that is the sentence with a close proximity to the question. You probably will expect an answer from your Q&A system if you use it. So it could be the answer, the traveler. Okay, who got the medical treatment? Traveler, because traveler got snake bite. Something like that. I hope this made you clear about how we can apply this vector embedding to find out a context to generate an answer in a Q&A system, or to extract an answer from for a Q&A system using the vector embedding, sentence vector embedding, to find get the semantic similarity between the question and the words or documents, sentence or documents. Okay, so now let's try to understand about sentence vector embedding in detail. So what it is actually, we learn the practical application with an example. So sentence vector embedding, mapping the sentences to vectors of real numbers, we saw that. And each vector component represents a different aspect of the sentence. We also explored that, and we explained that in detail. The vector embedding gives computers the ability to compare them and understand their meaning for natural language processing tasks. We also looked at it in the example, right? So what are the methods? So those are the methods you can use. Again, this is not very important for you to understand for the specific application, but for your general understanding or to learn further, you may need to learn a little bit more about neural networks and the different architectures. So the hidden layer output from of a transformer model like BERT, so will be one method. You can get the sentence vector embedding, and then you can also use the aggregate word embedding vectors like word2vec. You can use in this case to get sentence vector embedding using the vector as a word vector embedding. So there are different methods you can get the vector embedding done, but we are going to use some of the methods already available to you to generate embedding vectors for the document sentences we are going to explore in a practical application with Python. Okay, so now let's look at what are the things can help us to store this vector embedding, because now you know, like, you can get a document, you can get a vector embedding for the sentences or paragraphs, then you have to find a way to store them and to retrieve when you wanted to search them. Vector databases come into help in this case. You can employ the vector database to store data as high dimensional vectors. You can get your sentences or paragraphs or documents into vector embedding vectors, and you can store in vector databases. You can use vector databases using to store the vectors and the numerical representation of features and attributes of data elements. We talked about it earlier. So these vector databases you can not only use for text the vector embedding from text data, but you can use for other data types as well. When we wanted to convert data into a vector database compatible format, we are transforming raw data using the embedding functions. So we are going to use them, the pre-trained model embedding functions available in open source tools and framework to create this vector embedding. And then vector databases are used to implement efficient and accurate similarity search and data retrieval. So we will be using one of the open source vector database or vector database vector store in our application to begin with, but there are some advanced vector databases available. Both you can install or you can use on premise, as well as you can use as cloud services. All right, so let's move forward with that. So then now we learn about what language model is doing, how we can get the data, and we can get help from the semantic similarity to find out relevant context to give the answer to a question. But now to get that embedding vectors, we need, like I mentioned earlier, we need to have smaller chunks of data. Like, if you have a longer document, you may need to part it into like small pieces. How we can do that and how we can use those parts to store in a vector database, that is what we are going to explore here. Assume you have like a big document. You can chunk the document by employing different methods. Like you can have, like, I'm going to chunk every 100 sentences or maybe 50 sentences. You can say I'm going to chunk by tracking a paragraph pattern. Like if you have a multiple new line, 2 new lines, so that could be a paragraph or something like that. You can devise a method how you can chunk the document. Or you can say I'm going to track section headers. I'm going to chunk my document into parts following the section headers. Different ways. Somehow you decided to chunk it, and then this is the first chunk of your document. So that chunk, we will take it out, we will create embedding vectors, and then we can store in a vector database or vector store. When you are storing, you create an index to identify the record, and also you can store metadata. Like we are showing in the red leftmost box here, you can store actual text value of the document, and also maybe the page number, paragraph number, section number, any metadata you would like to store, you can keep it here, along with the vector, embedding vector, and the index. Like that, you can chunk this document into multiple pieces. So here we have 3 chunks coming from this document. All right. So these documents can be docx file, the Word documents, or PDFs, or HTML, or could be plain text documents. You can chunk it, create embedding vectors, store in a vector database with index, and you can also refer to the metadata. So now we know like basic components in a Q&A system we wanted to use. Now let's try to understand about the building architecture of this AI-powered Q&A system. So we are going to explore here retrieval-based question and answering application. So let's try to understand its component in detail from extended knowledge from our very first discussion on this topic. The first part is the document text extract and chunk. The second part is, we learned about it in previous slide. And the second part is embedding vector generator. We talk about it as well. Third part is document store or vector database or vector store we can employ to store the embedded vectors and to help the retrieval. And then of course you need to have information retrieval component to search in the document store and get the relevant content out of the document store. And then you need to have answer generator, so which is basically the language model you're going to employ here. And the last component, and could be like a very important part if you wanted to let user to interact with this system, you should have an interface. That's the user interface. Okay, so now let's look at how we can use this, how we can build each component of this question and answering system by step. So I'm going to guide you through conceptually step by step, and later in the practical exercise I'm going to build with Python code. For your understanding here, I'm going to do it one by one, like step by step. For the basic or the beginning of this work, we need to have some document processing tool. Based on the documents you are going to use in this application, it could be Word documents, it could be PDF, it could be HTML documents or plain text. Based on that, you need to build something to process them, to extract data, extract text out of the document. You need to have the document processor component. And then you need to have like a vector database and some component to interact with it as a knowledge base. That is where you're getting the information from the document processor by using the documents you have and then storing in the vector database. Optionally, you can use some question bank in some situations. You may have already answered questions. Sometimes in your organization or in your website, you may have frequently asked questions. Those you can consider as a question bank. You can also convert them into embedding vectors and store in the knowledge base. You will store the documents, and also you will have the frequently asked question or previously previously collected question and answering pairs. You can store in the knowledge base. So that is the first component you're building in the actual system, but document processor is a component will help you in the data ingestion process. Okay, so now let's think we got the data ingestion process done. We converted all the documents we have into embedding vectors and store in a vector database along with the optional question bank data. To do that, actually I forgot to mention, what we need is the third component, which is the embedding vector generator. This is a very important thing I missed actually. So that embedding vector generator will take the text data you extracted from document processor and creates embedding vector before it store in the document store, like the vector store. Alright, so now we think we can assume we have the knowledge base created. Now let's build the other components. Other components are retriever and ranker. So which we will be using to retrieve the relevant context from the knowledge base. When we retrieve relevant context from the knowledge base, say like you have multiple documents split into multiple chunks, you may pick a number of documents when we retrieve relevant content. Sometimes if you have like thousands of chunks in this knowledge base, for a given question, you may pick like maybe 10, 20. You cannot use all of them in your question answering process. So therefore, we need to prioritize. What should I use? In that case, you need to rank it. So that's why the ranker is important. You have to retrieve. At the same time, the retriever is supposed to rank them by giving a score or ranking order. It should say this is more relevant than the other one. So what is the highest relevant one? What is the lowest relevant one? Based on that, you can decide how many document chunks or parts of the context you need to feed into the question and answering system. That is the task of retriever and ranker. The next important piece is the prompt assembler. We will talk more about it later. That will assemble your prompt. We learned about the prompt in the previous slide. So that will assemble it using the question, whatever the retriever found in terms of the context and instruction, everything together, it will assemble and send the question to the language model. There's another component in this slide which is I consider as optional, which is called question parser. So what it does is, when a user sends a question, that question could be having some ambiguity, could be some typos, could be some ambiguous way of asking the question. It is good to have a question parser in that case. It could be using frequently asked questions to match against the already known question, or maybe some other way to reduce that ambiguity in the question before you are sending to retriever or the language model. That could be an optional thing, but at the beginning you may not need to have that component, but I'm going to introduce to you here and describe it in detail in the next step as well. So what is going to happen when you ask a question? So in the question parser, so question parser will take the question in and then do some processing, and then it will send the question to the retriever and ranker to get the relevant knowledge. And then your knowledge base is supposed to get the match document sections into the retriever with rank, and then those will be sent to the prompt assembler. So taking the question or the query as well as the relevant documents, the prompt assembler will assemble the prompt. So let's look at the next step. We are going to introduce another component to the system, which is the Q&A reader for the Q&A bot or the language model. So what it is doing actually, the language model we discussed earlier supposed to get the prompt as input and produce you the output to the user question. So this is what the process looks like. It takes the query or the question in, and it will now at this time your question parser is active. It will do the embedding. So it will embed, create embedding vector for the question, and then it will search in the knowledge base for a similar question and also do some processing to reduce ambiguity and make sure you are asking a more effective question from the system. And your refined query will be sent to the prompt assembler, and the prompt assembler will call the retriever this time. It will send the refined query to the retriever, finding out the relevant document content, and then assembling the prompt. And after that, it will send query plus knowledge. If the instructions are given, with instructions. If the chat history is given, with the chat history. It will give everything to the language model. And the language model is supposed to generate the answer. It could be a generative answer. It could be generative plus extractive answer. It will be provided to the user. Now, so our system is now complete. We have all the components in a working state. What is the missing piece? For a user to interact with this system, user should have an important component to ask question and to get the answer back. That is the interface. So in the next step, let's try to add interface into the system. So in this step, we added interface. So now let's see the process again. User is going to ask a question using natural language. Then the question or the query will get processed and do the removing the ambiguity and for processing the question. And then as usual, it will send to the retriever, and the retriever will supposed to get the relevant document content to the prompt assembler. Prompt assembler will assemble the prompt, send to language model. Language model will generate the answer. Through the interface, user can get the answer now. So this is the typical flow of things happening in a question and answering system after we build the system. I'm going to go through this example in Python exercise we are going to do in the next video. Okay, I hope this helped you to understand the concept. I'm not going to do this question parser step in that video, so that makes things a little bit of complex for a basics example, but I'm going to describe it in a later time with an advanced example. But other components, I'm going to use it as it is. I hope this made things clear to you, and you understood what is happening in this simple question and answering system with a generative and extractive capability. And we are going to move forward with our lesson, and then in the next video we are going to build this system actually with Python and other open source frameworks and libraries available. All right, so this is the full diagram of the system we are going to build, and then we are going to use these libraries. You can see from these icons for different components. I'm going to choose between the open source framework and libraries available. So this, the parrot and the chain symbolize the length chain, that is the symbol or the logo, and the Hugging Face, you all know it, and the haystack is another framework you can use. This length chain, Hugging Face, and haystack, so they work together, and you can build application interacting each library or each framework within your application. So we'll build one, and we will learn each of these components when we are building things. Okay, one important thing I forgot to mention about the interface. So we're going to build a web interface. So this interface could be a GUI you can create, or web interface. You can build easily a Python using Python programming language. You can use a library called Streamlit. This library allows you to build web interfaces or web application with less effort. As a data scientist or a person working in data science domain, machine learning, AI, this could be a very useful library. You don't need to work on HTML or any other programming language to build web application. You can basically code it in Python with fewer codes, and you can build very powerful and very user-friendly applications using the Streamlit library. We are going to build our interface using Streamlit in this application. All right, so now we talked a lot about the application we are going to build next. Now let's talk about some challenges in implementing a Q&A application or Q&A system. So what are they? So one challenge is scalability. So it could be a data-wise scalability, means like you may have like more data coming into your application. You need to have like a lot of data to be included, and it is getting increased. So your data-wise, you need to expand or need to scale up. The process-wise, you may have more users start using it. You need to think about like having a higher rate of processing the questions, right? Or you have to reduce the number, the time to give an answer. Like the process-wise, you need to scale it up, and you need to find the reliability, or you need to improve the reliability of your answering and your system at all. So if you have large number of users interacting on the same time, your system should not fail. Your system should respond on time. Your system is supposed to give the factually correct answers. It cannot give incorrect answers, or it cannot create any ambiguity in your application, especially if you are using it for a mission critical application. If your question and answering system is going to give wrong answers to the users of it, those users may use for something very critical, it is going to be a problem, right? You need to think about those challenges. And security and privacy. This question and answering system may expose users outside your organization or even within your organization. You need to think about the security and privacy of the users, what they are going to send in, and what are the things are being used consumed by your application, and what are the things being stored in your application. Is there anyone can take over your application, any security loopholes you have it, so hackers can come into your application and do something harmful. So you have to think about it, how you can protect if the user is interacting with your Q&A application, sending some sensitive information. Generally you're supposed not supposed to do, but in some situation it can happen. So how we can protect privacy of the users, or the question, what questions they ask, we should not give it to hands of the harmful actors. Those things you need to think about. Those are the challenges. And then one challenge, we already overcome that challenge by using the method. So finding relevant context for the user query. Like we now going to use the semantic similarity to find out the relevant context, but there could be some challenges implementing that. I will explain some of them in the next slide. And then understanding the user question. And sometimes user question may have some ambiguity, the way it asks, and maybe some typos, or maybe some syntactically issues could be there, right? So understanding the user question and resolve ambiguity could be a challenging part. That is why I suggested to have the question parser as a component into your application. And then you may have some leaks from the language model, because those language models are trained on data set, like a diverse data set. So language model may have some understanding of the context or the topic the user asks, but you may not wanted to use the language model to give the answer, but you wanted to use language model to synthesize an answer based on the context you find from your own documents. Okay, that is why it is very important for a Q&A application to accept instruction. If your language model can accept instruction and work accordingly, that would be the best model you can use in such application. Because you can say, don't give any answer outside the context you are giving. You can limit your chatbot to answer only to the question in your domain. For example, if you're building a chatbot for HR or human resource related question and answering, you can say, don't answer anything outside the context you find. Don't answer anything outside the human resource management context, or not anything outside your organization. That chatbot not supposed to answer questions like how is the weather today, or something about some drama, or like a movie. So those general questions that chatbot not supposed to answer, but it's supposed to answer only for the relevant questions given proper instructions, right? So therefore we have ways to prevent leaks from language model by having some proper guidelines to system instructions. So the other challenges could be keeping chat history, like we already looked at it earlier. So we've seen some question and answering, you may need to track what are the previous questions this user asked from the system. So you may need to have that chat history. So this could be something related to security and privacy, because chat history is something we should not give to a bad actor, because a user is going to chat with your chatbot with confidence and having some trust on you. If the chat history is leaked to a bad actor, so that trust is broken. So you need to keep that in mind. And also keeping the chat history could be a processing challenge, because chat history will make your prompt lengthier. How we can handle that? Those we need to overcome. The other item is the preventing hallucination. So hallucination is, we cannot say the leaks, because in the leaks from language model means the language model is using some information or context from its training data. Sometimes language models hallucinate, like human does in some situations. They can make up their answers without even a single thing found in the context or in the training data set. Those are like completely made up answers. So those can happen. We need to prevent them from happening. One great way of doing that is having your question and answering system using external resources. So retriever based question and answering system will prevent the hallucination into some level. Okay, so that is one major challenge we may have using this language model. Now you can understand the language model is not a silver bullet all the time. People need to build these tools with care to get the best use out of it. And another challenge will have in these language models are validating answers, because with could be hallucination, could be leaks from the language model. These answers you're getting from the language model will change time to time. You're not always getting the same answer if you ask the same question for the second time. I will show you some example in the video, practical video. So that the validating the answer from the large fluctuations, right? So this answer can change over time when you're asking the same question again and again. Therefore, it could be a broad range of correct answers, but how we can validate. So these are the things you need to pay attention, how we can validate these models, how we can validate your system to give factually correct, as well as it should be relevant to the question. So these things we need to pay attention. Those are the challenges. We have to face these challenges when we are building this application. I hope this made you clear about things you need to know about the Q&A application. And now let's look at something about data. Okay, so these are like more challenges about the data we are going to use in this Q&A application. If you're going to use it as a extractive based Q&A application, you need to feed data in. We talked about data extraction before, but this we are talking about some challenges at this point. So think about this document. This is a Wikipedia article. So this Wikipedia article, we have several items. So we have paragraph text, we have section headers, we have images, right? We have tables and lists. So various different data elements. So when we are extracting this information, we are extracting text. Okay, we can easily extract paragraph and convert into embedding vectors and put into vector store. But how we can deal with the tables and images? That's going to be a challenge, right? Tables, we may need to process it. Images, we need to do certain processes. Let's look at the structure of the document first. So think about this document. It has a structure, like it has a section header or topic, and then you have subheaders. Under that you can have paragraphs, and you have some document structure. So you need to have some string pattern matching to understand the document structure if you were to chunk or to categorize the different chunks based on, or index those chunks based on the sections or the section headers. So you can apply some string pattern matching. You can use OCR to deal with images. Optical character recognition, or OCR, can read content from the images. If the images having text input, you can read them and then use them as the text content for that image. And also you can read the image captioning, alternate captions embedded in the images. This could be in a Word document, it could be an image caption in a PDF document or HTML. You can read the content out of it, and you can use them as the materials you need to embed and store in document store. What about the tables? And what about the lists, right? So before that, let's look at the document layout. So altogether, we now have like different components. We can use the document layout models, which will take the visual appearance of the document plus the textual content of the document, and then we can use this to extract and understand what the document is. Those are the document layout models. Using them, you can extract parts of the document and index them properly. We know like this is coming from this region of the document, and this is coming from this region of the document. Like that, you can use document layout models to do your indexing more effectively. Therefore, your retriever can work better. We can improve the quality of the retriever by employing those document layout. The last item I wanted to comment is the tables and lists. So tables and lists are harder to extract as it is, because if you extract a table as a text, it could be like just bunch of text values and numeric values. So the table structure may destroy. For that reason, we may employ a special model for table question and answering. So there are models specialized in doing the question and answering on tables. For example, in this document, we have a country and we have the population. If you wanted to find out what is the world population something like from the table, you should be able to get sum of the population in all the countries, and you should be getting the answer. That is kind of a simple data analysis task. If you use a table question and answering, so that should be able to process that. And not only that, it should run simple queries, like you can say, what is the population of United States? So it should be able to read the relevant row and then find you the answer. Like that, the table question and answering models can be employed together with the large language models to help your question and answering task. Or you can use table question and answering at the early stage of extracting content. You can extract several things, or maybe you can summarize this table and put into the document store after embedding it. Then when user asks a question, that summary should be able to provide you the answer. Like that, the designing of the question and answering system, it varies based on your requirements, but you have all the tools available. You have string pattern matching methods, you have OCR methods to convert images to text, you have document layout models available, table question and answering models are available. You can employ all of them together to build a very complex question and answering system using your own data. All right, so now let's put them together. So what are the challenges in processing data? Document structure, presence of tables and images, inconsistent style and formatting. For example, if you wanted to get your headers, section headers, and paragraphs, if those are not formatted carefully, whoever the person created this document, that could be a challenge for you to extract them properly. And difficulty to split into cohesive parts. Sometimes if the relevant content of the document cannot be split into parts accurately because of other issues, formatting issues, because of the way the document is organized, that is going to be a problem. And then generalizing the extraction method, because if you are an organization or your document store has maybe thousands of documents, those could be various different types, or part could be documents in Word docs, docx files, could be PDF files, could be HTML, could be plain text. Various types of documents can be there. You cannot easily generalize a method to have like all 1,000 documents, but you should not have a method to extract information from one document to another. You may have like a similar documents you can extract following the same method. Therefore, you should take that as a challenge. You can generalize as much as possible your extraction method. And then the difficulty to locate tags for content, like I already mentioned to you, that could be related to styles and formatting. If you're capable of finding the headers and topics by HTML or docx or PDF document content, so that will be a very good thing. But if you cannot find it, so you face additional challenges. Okay, and sometimes we get document readability. So some documents are corrupted, we cannot read it. Sometimes those documents can be read only using one type of application. For example, a document can be read only using Word application but not in Python. You may have some challenges. In those situations, you may need to convert this document into another format like PDF and then use your PDF reader to extract information. Some alternatives or workarounds you may need to employ in such situations. I hope now you have a good understanding. Don't be fear about these challenges. We have methods to overcome many of them, and in the future, because this is kind of an evolving field area, right? So people building new tools, new methods, and new platforms and frameworks. So you get a lot of help in the coming days. But you need to understand these challenges and take it and then overcome with it. All right. So now let's try to do some building. I'm not going to do it in this video, but I'm going to give you some introduction of what we are going to do next. In this next video, we are going to build a Q&A chat application by using Hugging Face AI community resources, as well as using other frameworks such as LangChain, and we're going to use sentence transformers, Haystack, and of course everything will be running either TensorFlow or PyTorch, kind of neural network based frameworks, right? So these are the things we are going to cover in the next video. I hope this helped you a lot, and I hope you will also join my next video, how to build a extractive and generative chat application to get answers from your own documents, right? So I hope to see you all there, and see you in the next video.